Hello and welcome back to computer programming. So today we're going to continue our look at functions, and specifically we're going to focus on something called the return statement. So just a general reminder, to get the files, you're going to need to click on the zip file that's included with the assignment. All right, it's going to tell you that it couldn't preview it. It's going to give you this page, which we don't want. You're going to go to open in new window. All right, and then now you should have the download icon that will send it down to your computer. Now, you might get a warning that it's an infected file. I'm hoping that you're still going to be able to download it. If not, we'll find a workaround, but you can download the infected file. It's not actually going to cause any problems. And then it's going to end up in your downloads folder, so you can open up Windows Explorer or the File Explorer. You should see the zip file right here. So you can always right click on that and choose extract all. All right, this should be fine wherever it sends it. You can hit extract. Again, it opens it up in a separate window, but I like to close that window and then delete the zip file because you're not going to need it anymore. And then once you've deleted the zip file, I also like to basically drag this new file into my computer programming folder just to keep everything nice and organized. All right, once you have it in there, then you can go inside and open up the actual program. Now the file that it said was a virus and was contaminated is the solutions. This is what the final product is going to look like today. So this is something that you can use to check your work as you're going through the lab, but we'll get to that later. So again, you just want to open this project file, not the main one. That's the file you turn in. But when we're opening it, we open up the project file. So you can just double click on that. And it should open up code blocks if we give it a second. Wait for it. Wait for it. All right, there it is. You should see all of this code right here. Again, if you don't, you can go over to this navigator window. And if you're on the projects tab, which again, there's arrows to go between the different tabs, it'll be in the sources folder, and then just double click on the main.cpp there. All right, so 1 second. All right, so let's take a look at what we have here. All right, so up top, we have our include statements. All right, so this is including just the CST standard library, the IO stream, and the string library that we saw last lab. Then we've got our function declarations here. So there are 4 functions that are part of this code right now. Square, triangle, rectangle, void square. And those functions have various parameters. So this one has a parameter side. This one has a parameter base and height. This one has a parameter length and width. And this one has the parameter side. And then we have our main function. All right, so these are all variables. So this is a variable called shape. And then these are float variables, meaning they can store decimals, called length, width, and answer. And then we have a cout statement that says what shape do you want to find the area of? Square, triangle, rectangle, and then however you want to pronounce that. We'll say trirect. I think that's probably the best pronunciation, trirect. And then we allow the user to type in their answer, and that answer is going to be stored in the variable shape. So at this point, we go into a series of if statements. So if shape equals square, we're going to run this code right here. Else if shape equals triangle, we're going to run this code right here. Else if shape equals rectangle, we're going to run this code right here. Else if shape equals trirect, we're going to run this code right here. And then else is sort of the default scenario. So if they type in a shape that we don't recognize, we're going to give them an error message that says we don't recognize that shape. All right. So basically, we have this sort of menu selection where the user can type in one of those 4 words. And if they type in one of those 4 words, they're going to get specific code that executes. And if they don't type in one of those 4 words, they're going to get this default error message that says, I don't recognize that shape. All right. Now, as far as what each of these functions do, they basically calculate area. So this is a function that's going to calculate the area of a square. This is a function that's going to calculate the area of a triangle. This is the function that's going to calculate the area of a rectangle. And then this is a different one that we'll talk about towards the end. All right, but basically we're calculating areas. So length times width for a rectangle, 1/2 base times height for a triangle, and then the side squared or side times side for a square. All right, so there's a lot going on here, but just realize at the base of it or the crux of it, we're just calculating areas. So it's really not as complicated as it might look at first glance. So how does this all work? All right, so let's just say that they type in square. All right, so we put out a little message that says enter the side. We read that into our variable length. And then we have a cout statement that says the area of the square is, and then this isn't a variable, this is actually a function call. So this is saying, hey, go use the function square and pass it in the value length. All right, so this is the value that's going to get passed in to my function. All right, so when the program gets to this, it's going to jump down and execute the code inside of function square. All right, so if I go down here to function square, I can see that this function has a type called float, which is a little different than the functions we looked at with the old McDonald program, because all of those were type void. And I said, don't worry about that right now, just keep using void. Well, now we're going to worry about it. All right, now we have a type of a function, and this one is called float. All right, and the type of the function relates to this return statement down here. All right, so let's just see what this is doing. All right, so we've got this parameter side. So again, the variable up top there when we called the function was length. So we passed length into the function. That value gets stored inside the variable side. So again, it's almost like I did this, float side equals length, where that value of length is now being stored in the variable side. Now, I don't actually write that code. It happens automatically, but that's effectively what's happening. So I now have a variable side that has that length that the user typed in stored inside of it. I'm creating a new variable called answer. I'm saying answer equals side times side. And then I have this new thing that says return answer. Right? And this is basically me sending back a number or sending back a result. All right? And the type of function, in this case float, specifies what I'm sending back. So I'm sending back a float answer. I'm sending back a float variable. I'm sending back a float value. All right? So the type of the function matches the return statement. All right? If you create a float function, you should be returning a float value. If you create an int function, you should be returning an int value. If you create a string function, you should be returning a string value. So whatever type of function you create, you should be returning the same value. And what happens is that value basically just takes the place of the function call. So, let's just pretend the length side was 5. This is going to calculate 5 times 5. It's going to get an answer of 25. And that 25 is going to get plugged in right here. All right, so this is going to print out the statement, the area of the square is, and then that value 25 is going to get plugged in right here. It's going to print out the 25, and then it's going to print out the period. All right, so the return statement allows us to basically send back an answer or send back a value. Now, let's take a look at the next one. All right, so this one says shape equals triangle. So triangle, instead of asking for just a side, I'm asking for a base and a height. Now, I'm storing that in the variable length, and I'm storing it in the variable width. You might be saying to yourself, but you asked for a base and the height. Again, the user doesn't know that I stored it in a variable called length and width. All right, this is all invisible to the user. I just stored it in length and width because those were the two variables that I made at the start, so I'm just reusing those variables. Could I have made separate variables called base and height? Sure, I could have, but I didn't in this case. I just used length and width because, again, the user doesn't know necessarily what your variables are called. All right? I then send both of those variables to the function triangle. All right, so if I scroll down now, I can see that there's a function triangle. All right, it has two parameters, base and height. So those two parameters are going to get the two values that I passed in. So base will get whatever value was passed into length. Height will get whatever value was stored in width here. All right, so again, it's not explicitly there, but it's basically like I said, float base equals length, float height equals width from up above. All right. Again, it all happens automatically, but that's effectively what just occurred. Now, if you'll notice up here, I said like float answer equals float answer, created a variable, and then answer equals the calculation, and then I return the answer. You can also just return a calculation. All right. I didn't actually need to make this variable answer up here. I could have just said return side times side, and that's what I'm showing down here. All right, you can return an entire calculation and say, all right, return 0.5 times base times height, and that answer will get plugged in for my triangle here. Now again, here I printed out the answer directly, which is fine, but I could also take that answer and store it in a variable. All right, so here I stored my answer in a variable answer, and then I just printed it out to the screen. All right, so the return statement's versatile. I can put it as part of like an output statement and print it straight to the screen, or I could save it inside of a variable and then use that variable later on in my program as either part of an output statement or something else. All right, so let's actually just run this so you can kind of see it in action really quick. All right, so let's say I wanted to do a square, and then I enter the side length. It's going to tell me the area is 36. All right, if I run it again and say this time I want a triangle, and I'll put in a base of 10 and a height of 2, it's going to tell me the area of the triangle is 10. All right. Now, let's try it one more time with rectangle. If I put in a length of 5, a width of 4, it tells me that the area of the rectangle is 1.01933 times 10 to the negative 38th. It's kind of weird. So let's take a look at the code and see what happened there. All right. So it starts off the same way. I say enter the length, type it in. I say enter the width, we type it in. And then I call the function, but notice I didn't do anything with it. All right. Up here, I called the function and I put it directly in an output statement. Down here, I called the function and I saved it into a variable. All right. Down here, I called the function and I didn't do anything with it. All right. It's its own line. All right. When you do that, it's going to return a value, but that value is just going to disappear. All right. So if we look down at the rectangle function, all right, I just do float answer equals length times width, and then I returned answer. All right, so it's very similar to all of the other ones. It's just doing the area calculation. The only difference here is here I declared the variable, then did the calculation, then returned it. Here I just returned the calculation. Here, when I declared the variable, I did the calculation at the same time and then returned the variable. Again, they all work the same. So it's just showing you three different ways that you can effectively do the same thing. So this answer gets returned. It gets sent back up to our main program, but then it just kind of disappears. All right, it's kind of vanishes. Like I didn't tell it to print out to the screen, so it doesn't print out to the screen. I didn't save it in a variable, so the computer doesn't hang on to the value. It basically calculates the value, it puts the number in, and then it disappears because we didn't tell it to do anything. So when I print out answer, I'm just getting the uninitialized value of this answer variable. Now, I don't know if you remember that, but earlier on I said if you don't give a if you don't give a variable a starting value, you have no idea what's in it. All right? Like it's just whatever happened to be in that location of memory. So when I print out answer, all right, I'm getting this because that's what happened to be in that spot of memory. I didn't, set it to anything. I didn't declare it. I didn't give it a value. So I end up with just that random, 1.01933 times 10 to the negative 38th. All right. So again, if you use these return statements, you have to do something with the value. All right. So if I were to add answer equals rectangle, now it would work correctly. So if I were to close this out and rerun my program, wait for it, and then say that I want to do a rectangle, all right, now it's going to work correctly, right? Because I'm doing something, I'm making use of that returned value. So last we have the trirect. So again, with a trirect, we're asking for a length and a width. And then the only point of this trirect is to show you that you can also use return statements as part of a larger calculation. All right, so here I'm using all three of my functions, and they're part of a larger calculation. So they're each going to return a value. This value will get returned, this value will get returned, this value will get returned, and I can just add those together as part of a larger calculation. All right, so when you're returning values, you can either print them out, you can store them in a variable, or you can use them as part of some larger calculation. So if I were to run this again, make sure I spell this right, trirect, all right, and then I'll just type in 4 and 5. All right, it's basically calculating the area of a triangle, a square, and a rectangle, and then just adding them all together. All right, so the return statement, very versatile because you can do all sorts of things with it when your function is returning a value. What I want to do is compare that to the void functions that we looked at last class. Now, there is a time and a place for a void function, but generally they are less versatile. So here I have a function called void square. All right, creates a variable answer. It does the calculation. And then the output statement is directly in the function, all right? Because void functions can't return a value. You can't have a return statement in a void function. So if you want to print something out to the screen or you want to display your answer, you've sort of got to hard code it in there. So if I were to go up top here and add a call to my void square, so I'm just going to go to the very top of my main, and I'm going to call my void square, right? And then I'm just going to give it a value of 10. That's going to call my function. It's going to bring it a 10. It's going to calculate it in an area of 100, and then it's going to print out the statement. So if I run this, there's my output right there. It says the area of your square is 100, right? It did exactly what I wanted it to do. But watch what happens if I try to use it in the same way we just used a return statement. So if I say x equals void square, I'm going to get an error message, right? Oh, I'm going to get an error message because I didn't call it a variable. Let me say, if I say int x equals void square, I apologize. I'm going to get an error message that says void value not ignored as it ought to be. Basically saying, I can't set x equal to void square because this doesn't return a value. It's not sending anything back, so this is an invalid statement. All right? If I tried to see out void square, I'm going to get the same sort of error. It's just going to be a different error, but it's the same problem that I can't output this because it's not returning anything. You know, if I tried to use it as part of a calculation, int x equals 7 or 6 times void square, it's going to give me an error because, again, it's not returning a value. All right, it's very one-dimensional. It can do this calculation, it can print out a message, but that's it. All right, like versus the return statement, I have all sorts of flexibility and all sorts of functionality that I can do with it. So if I did this and I said, oh, square, 6 times square 10 plus 23 minus, I don't know even what I'm doing right now, but this is valid, all right, because this is going to return the value and use it as part of the calculation. If I want to print out square 10, this is valid because it's going to return a value and then print that out. If I want to store square 10 in a different variable, that's valid, all right, because it's going to return a value. There's a lot more that you can do with return statements than you can do with functions that are of type void. So a lot of the functions that we're going to be writing going forward are going to have a type, all right, and that type might be float, it might be int. It's going to be, most of ours are going to be float and int, but it pretty much can be any type that you have a variable for. There will be times and places for void, but more often than not, we're now going to be using these functions that have return values because they allow us to kind of do more things with them. All right, so that's kind of a rundown. Now, what you're going to be doing today in your lab is writing a whole bunch of functions that have return statements. So what we're going to do is we're going to do one together, and then there's 3 more that you're going to do on your own for the lab. So first thing we're going to do is we're going to comment out everything that we have here. So I'm going to go right below using namespace standard, and then I'm going to do my / and my star to comment out all of this stuff. Then I'm going to go right above this int main that I have down here that's already been commented out. And I'm going to do */, and then I'm going to delete the / here and delete the */ down there. So effectively what I've just done is I've commented out everything that was there except this stuff at the top. And then I've uncommented this empty main function down below. All right. So the first thing that we're going to do is we're going to write a function that returns the area of a cube. All right. So our function is going to calculate the volume of a cube and return the value. All right. So the way it's going to work is we're going to ask the user for the information in our main program, and then we're going to do the calculation inside of our function. So I'm going to start by making a variable called cube side. So int cube side. And then I'm going to ask the user to type it in. So I'm going to say, please enter the length of a cube side. And then for formatting purposes, I'm just going to put a colon, a space, and close my quotes. Then I've got my semicolon there. And then I'm going to do cin cube side. Okay. So now I have a value called cube side that's being stored in a variable. I'm going to then call a function that's going to do the calculation and then print out the result inside of my main function. All right, so let's go down here and let's create a function. So this one's going to be called type int, and we're going to call it cube volume. Okay, we've got our left and our right parentheses. So again, this is the type of our function. It's type int, which means we're going to be returning an integer value. This is the name of the function, cube volume. And then inside of here, I can put any parameters that I want. Now, to calculate the volume of a cube, I need to know the length of the side. So I'm going to create one parameter of type int, and I'll call it side length. That's the name of my parameter. Then I'm going to hit enter, and I'm going to make my curly braces. So as I kind of showed up here, there's lots of ways to do the return statement. I can either do it directly, I can create a variable, I can do the calculation why I'm creating a variable. I'm going to just go through and create a variable, do the calculation, and return it all as separate steps because I think that's useful early on. So I'm going to say int volume. All right, that's going to be the variable that I've created. I'm going to say volume equals side length times side length times side length. And then I'm going to return volume. All right, that's going to send back the answer. All right, so it's going to send back an answer to the main function. Right. So up here in the main function, I now actually have to call and make use of my function. All right, so I could put in a function call. I could say, oh, cube volume, and I'm going to pass it whatever value is inside of cube side. Now, if I just do this right here, I'm going to run into the same problem I ran into with the rectangle. It's going to return the value, but it's just going to disappear in thin air. So I either have to print it out directly, so I could do something like this, see out the volume of the cube is, and then call my function. Just doing some formatting here. Right, this would be one option because it's going to send that value right here and make it part of this output statement. Or I could create another variable. Let's just say something like int answer. And then I could say answer equals cube volume, cube side, and then print out answer in a separate line of code. Right? But you have to do one or the other. You either need to print out the answer directly, or you have to save the answer inside of a variable. Otherwise, it'll just disappear into thin air. All right? But if we were to run this and test it out, we're going to get an error. All right, because I forgot to put in the function declaration. All right, so it's the compiler's getting to cube volume. It's saying, wait a second, I don't recognize what cube volume is because I didn't put in my declaration. So I'm going to take this right here. I'm going to copy it. I'm going to put it up above my main and then have a semicolon there. All right, so now if I rerun this, once it establishes that it's not a virus, it's going to ask me for the length of the cube side. I'm going to type in 5, and then it's going to tell me the volume of the cube is 125. Okay. So that's the sort of thing that you're going to be doing. All right. Now, if we take a look at the lab document, you're going to see that you are responsible for writing 3 functions. All right. The first function is going to calculate the volume of a rectangular prism. So it's going to be very, very similar to what we just did. All right. In the main function of your program, you're going to ask the user to provide a length, a width, and a height. You're then going to write a function that accepts those 3 values as parameters and uses them to calculate and return the volume. All right. You may use all integer variables for this exercise. All right. So that one can be typed in. The second one says, in the main function of your program, ask the user for a real number, meaning decimals are allowed, so you're going to have to use type float. Then write a function that uses an if statement to calculate and then return the absolute value of that number. So basically, if the number is negative, you're going to have to turn it positive. And if the number is positive, you don't have to do anything. You can just leave it alone. All right? But you're going to be writing a function that returns the absolute value of the number they type in. And then the last one says, ask the user to type in 3 integers and then use a function to return the value of the largest one. So for example, if they type in 8, 10, and 3, it's going to return the 10 because that was the largest value. Right? And you can see what this all looks like by running the function solution file. So if you run the function solution file, whoops. Give it a second. Again, it thinks it's a virus, but if you click on more info, you should get the run anyway button. And then you'll see it says enter the length, enter the height, enter the width, and it calculates the volume. It says enter a number, so I'm going to type in negative 7.6. It tells me that the absolute value is 7.6. And then I'm going to type in 3, 3, and 7. And it's going to tell me that the largest number is 7. So yours doesn't have to look exactly like this, but this is effectively what it's doing. All right. You're asking them for the values, then you're returning and printing out the answer. You're asking them for a value, you're returning and printing out the answer. You're asking them for the values, you're returning and printing out the answer. So all of the ask for the values should be happening inside of the main function. So again, you'll ask for a value, you'll store it in a variable, and then you'll call your function and print out the result. All right, they can all just go one after the other. So again, you'll start with the volume of the rectangular prism, and then below that, you'll do the absolute value. And then below that, you'll do the largest of 3 integers. All right, they can all be part of one big program. You don't have to comment them out as you go. Just do one after the other after the other. All right, but in each one, you're setting up a function, you're setting up the parameters, you're creating any variables you need, you're doing the calculations, and then you're returning an answer. All right, so I hope this was helpful. Obviously, if you have any questions, just let me know and we'll go from there. Otherwise, best of luck. All right, goodbye.